All right, here we go. Unit 3, Lesson 2, the quotient rule. So last time we learned about the product rule, a rule for taking the derivative of a function that can be thought of as two separate parts being multiplied together. And now we're going to learn a similar rule for two separate pieces that are being divided, right, which would be a quotient. So consider the function 2x cubed minus 3x squared plus 2 divided by x squared. A very tempting but wrong thing to do would be to apply the derivative to the numerator and the denominator separately. So this is the trap. The trap is to say, oh, I'll just apply the power rule. So this is 6x squared minus 6x. The derivative of 2 is 0. Derivative of x squared is 2x. So this would just be taking the derivative of the numerator and the denominator separately. This is tempting, but wrong. And we can see that it's wrong when we go ahead and we take f of x and we rewrite it simply using exponent rules. So 2x cubed divided by x squared is 2x. Negative 3x squared divided by x squared is negative 3. And finally, we would have plus 2 over x squared. Just a little bit more rewriting to get into standard form. This is 2x minus 3 plus 2x to the negative second, just so I can bring that up here. So this is now something that we can apply the power rule to. And so we could find correctly using the power rule, once we have this in correct form, that this derivative here is equal to, well, the derivative of 2x is 2, and the derivative of 2x to the negative second is negative 4x to the negative third. And so this is actually the correct derivative here. You could rewrite this in a bunch of ways. 2 minus 4 over x cubed. Whole bunch of different ways that you could write this. If you wanted it as one fraction, you could say this is 2x cubed over x cubed minus 4 over x cubed. Just trying to get this to see, like, what is this going to look like at the end of the day? 2x cubed minus 4 over x cubed is probably like the nicest final way of putting this. So you can, when possible, just divide through, convert to standard form, and use the power rule. That's our just bring the exponents down, multiply, subtract 1 from the exponents. But with the product rule, right, or with products, we learned there was a special rule, so we can do this with things like sine and cosine functions. There is also a quotient rule for differentiation. This is, again, something that you absolutely must memorize by the end of the year. This is a weird year. You're going to have access to your notes throughout, so something that you want to have handy. And what the quotient rule says, if you can think of h of x, so some function, as two other functions where f of x is divided by g of x, then the derivative of h of x, h prime, is, and if you can't see that there, that's f prime of x. That's f prime of x times g of x minus f of x g prime of x. So notice, I'll do a quick reminder here. Remember the product rule? If you're multiplying f and g, it would be f prime g plus f g prime. I'm doing super shorthand here, but it would be plus. The quotient rule is really important. This is a minus sign, so it's just like the product rule on top, but it's a minus sign. So it's f prime g minus f g prime. The order matters here, versus in the product rule, the order doesn't really matter, but I like you to always do it the same way as the quotient rule. All of that divided by the denominator squared. Not the derivative of the denominator squared, just the straight up denominator squared. So let's see what that looks like here for our problem from the warm-up. If we want to find, I'll go ahead and I'll label these all out just so you can really see them. F of x, well, that's just the numerator. That's 2x cubed minus 3x squared plus 2 in this situation. G of x, well, g of x is just the denominator, x squared. And while you're still learning this, feel free to just write all these things out, and then you can just put them all together. The derivative of the numerator, notice this is just the derivative of the numerator, is 6x squared minus 6x. And finally, the derivative of the denominator, g prime of x, is just 2x. And so we're going to put all these together using the quotient rule. We are going to have f prime, so the derivative of the first function, so there's 6x squared minus 6x, f prime times g, which is just x squared, all of this over, not done yet, minus, now we need f, regular old f, 2x cubed minus 3x squared plus 2, f times g prime, which is 2x. And all of this is going to be over g of x, which is just x squared, squared. Okay? So, boy, we've got a lot there. Let's go ahead and think about quick ways to simplify this down to show that it is still the same. Let's see here. So this is going to be, the first thing I'm going to do is I'm going to kind of cross this out here to save myself some space. This is x to the 4th power. One thing I see immediately is that we have, in terms of this portion, and the denominator, they all have at least one x that can be divided out of them. So I'm going to go ahead and divide out that x. So what that's going to leave us with, 6x squared minus 6x times, instead of x squared, that's where I'm going to divide the x out of the first term. So that's where the x cancels out of the first term, minus 2x cubed minus 3x squared plus 2 times 2. So notice I took the x out of the 2x and out of the x squared, and now all of that's going to be divided by x cubed. I don't know if I have any other fancy tricks here. This is just now going to be a combining like terms thing. So we'll have 6x cubed minus 6x squared minus all of, now we're doing 2 times all of these things, 4x cubed minus 6x squared plus 4. And all of this is going to be divided by x cubed. So what we have here is we have, first of all, with the cubes, we have 6x cubed minus 4x cubed. Well, that's 2x cubed. So now we've taken care of those. Negative 6x squared minus negative 6x squared, anything minus itself is 0, those are gone. And finally, we have minus 4. So 2x cubed minus 4 over x cubed. 2x cubed minus 4 over x cubed. 2x cubed minus 4 over x cubed. Now, this is a really good place to, again, show the quotient rule is not always easier. Maybe, and again, if it's a free response question on the calc test, you don't have to do any simplification. So if you don't have to do any simplification, you can stop here. And so in that case, the quotient rule might be easier. But where the quotient rule is really necessary is when you have things that cannot be simplified into polynomial form. And so let's take, for example, if g of x is the cosine of x over x cubed. So again, I can, I'll think, let me write this out. This is going to be f prime of x times g of x, just writing out the quotient rule here, minus f of x g prime of x. All of that is going to be over g of x squared. Okay? And so we write out all of these different pieces. And so first I'll just write out f and g. F of x is equal to the cosine of x, because f of x is what the numerator I'm going to label. G of x I'm going to call the denominator, x cubed. So that leaves us with the derivative of the numerator, f prime of x. The derivative of cosine is negative sine of x. And the derivative of the denominator, the derivative of x cubed, g prime of x equals 3x squared. So we have all our components here. Now we're just plugging them in, and eventually, again, you do this enough times and this becomes unnecessary. You just kind of do it as you go along. But if you're struggling with the quotient rule, it's a good step to take. So what we'd have here is negative the sine of x times x cubed. I like to put it in parentheses there just to make it super clear. Minus, and it's important to remember this minus sign applies to all of this. So minus the regular cosine of x times 3x squared all over g of x squared. So x to the third squared, that's x to the sixth power. Really, the only simplification I would do here is I would take an x squared out of everything. So I would finish this problem off by saying this is negative sine of x times x minus the cosine of x times 3. Notice I've taken an x squared out of both of those terms. All of that divided by x to the, take 2 away, x to the fourth. That's about as good as you can get with this one. There's no real further simplification. Okay, so last thing here today then, one example for us to try together. The number of times I'm going to have you find equations of tangent lines. Again, as soon as you see this phrase, equation of the tangent line, the very first thing you write before you write anything else is just to remind yourself, if I need an equation of a line and it's a tangent line, I need the slope of that tangent line and I need a point of tangency. So g of x is some graph. I don't really know what it looks like. You know, who cares really? But it has some kind of like a vertical asymptote at -3, right? Because as x approaches -3, we're approaching 0. Let's see, as we approach -3 from the right, we'll be heading up to, well, it'll be, so like -2. -2.99, it'll be a negative over a positive. So we'll be heading like, who knows, we'll be heading like down to -infinity. We'll have an asymptote at 2 and an asymptote at 2 the other direction as well. So it probably looks something like this, unless I've made like a mental math error. But the point is here, I want to know what is the equation of the line tangent when x equals, let's say, -2. So I'm looking for the equation of this line. Well, to find out what the point of tangency is, I just need to plug in -2. So the first thing I'll find is g of -2 equals 2 times -2 minus 1 all over -2 plus 3. That's going to be -4 minus 1 over 1. That's going to be -5. Okay, so the slope, or the point of tangency here, is -2 comma -5. Okay, and that's reassuring. That looks at least plausible with my graph. So we know that this tangent line touches g of x, right? It isn't g of x, it's a tangent line to g of x at -2 comma -5. So I have a point. I also need a slope. I need a slope here, and so to find the slope, I need to do g prime of x using the quotient rule. And so when we do the quotient rule, I'm going to do this one just straight out, right? F prime g, okay, f prime, the derivative of 2x minus 1 is just 2. G, well, that's just the denominator, x plus 3. So see there, take a pause, notice it's the derivative of the numerator times the denominator, minus the numerator, 2x minus 1, times the derivative of the denominator, the derivative of x plus 3 is just 1. All of this will be over the denominator, x plus 3 squared. Now, we can do a little simplification here. It's basically whenever you're ready to plug in -2, you're good to go. I'll just do a little bit of simplification here. This would be 2x plus 6 minus 2x plus 1. I'm just distributing here. That's all I'm really doing. The 1 doesn't matter. All of that over x plus 3 squared. So the 2x's will cancel. I'm glad I did a little simplification. 6 plus 1, we have 7 over x plus 3 squared. This is what g prime of x is. So g prime of -2 would be 7 over -2 plus 3. So now you can see why I just left that as is, because we're just going to get 7 over 1 squared, or 7. So the slope of the tangent line is 7. That means the equation of the tangent line, now this is just like plug and play, y minus y1 equals the slope times x minus x1. And if you are taking an AP Calculus free response test, you are done. You don't have to do any simplification there. You don't even have to make that, if it bothers you, you can totally make this y plus 5 equals 7 times x plus 2. And if it really bothers you, you can put this in slope-intercept form. You could say y plus 5 equals 7x plus 14. Y is equal to 7x plus 9. Hey, that looks, that looks plausible. Maybe that's 9 there. So anyway, the idea is here that you can stop whenever you want when you have that equation of the tangent line.